Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
So I search for a substitution for this IC, and once again it is a SI-1120H, and it turns out that one of my dealers in Singapore has the original one, and it is a Sanken, but it will cost the owner up to $30. And with shipping it will be cost around $75 just to get it. So what I'm going to do now, I'm going to contact the owner, brief him in the situation, and see what he wants me to do. So I contacted the owner and I briefed him about the condition of his unit, and I told him that in order I can repair it correctly, I need to order a new amplifier chip for it from Singapore, and it will cost him around $75. So he told me that he doesn't have a budget for this type of money, and he asked me if I can find another way to repair it in it. And I told him that the only other way that I can repair it correctly in it is to replace the entire amplifier board with a brand new one. And he agreed it. Also, we discussed the radio section and the tape mechanism section, and he told me that he doesn't use the radio often, but if it works, he won't mind about that, as long it doesn't cost much. As for the tape section, he doesn't use it at all, and in fact he asked me if I can replace it and installed an MP3 module instead of it. And I said yes. So what I'm going to do now, I'm going to design the new amplifier board, repair the radio section if it needed any kind of repairs, and replace the tape section with an MP3 module with a Bluetooth capability as he ordered. And after I will do all of these steps, we will see how the unit will behave. So here's the unit, has been completely repaired and also modified like the customer ordered. And in order so I can repair it correctly and also modify it, there were a number of steps that I had to do in order so I can get to this result. And now I'm going to tell you about each one of these steps one by one. Now the first step in the repairing process, it was removing this front control plate from its place in order so I can get access to all of the switches and all of the VR resistors they were installed behind it. And also I can get access to the tuning shaft slash flywheel assembly and to the band selector switch of the radio section. And after I remove the four screws that hold this plate into the body of the unit, and that is two from each side, I was able to remove it after I remove the knobs. And I started with the tuning knob. After it, I removed the volume knob, the balance, the treble, the bass key, and the record key. And this key, it has two separate knobs. The original design or the original key, and this is, by the way, this is the original one, it's still the original one. It gives the owner a choice in order so he can adjust the left and right signals separately. So after I remove these two knobs, I was able to remove this cover from its place with ease. After I remove it, I started cleaning the cleaning process with some compressed air and a lot of brushing. And I cleaned all of these switches and buttons using some cleaning solution. After that, I cleaned the tuning chata with the help of a brush. And after I did this step, I disassembled the tuning shaft slash a flywheel assembly in order so I can free it from seizing. And here is some pictures of the tearing down and disassembling process and the repairing process. So after the tuning shaft slash flywheel assembly it is repaired and duplicated, I reinstall it into its place, and after that I move to the radio circuitry. And I started with the band selector switches, and with the help of some cleaning solution and a thin cotton swab, I was able to clean them up and make them work like they should be. After that, I moved to a thorough examination for all of the component of this circuitry, and after the thorough examination it is done, I started testing with a multimeter, and the test shows that all of the parts seems okay and none of them appears to be blown or faulty. So I decided to power up this circuitry using a separate power supply, and once I did, the circuit or the radio circuit worked perfectly without any kind of problem. After I confirmed that the radio circuitry it is fully operational, I noticed that the tuning rail of the variable capacitor it is loose. So after some thorough examination of it, I found that the shaft in it, because of the age and time, it has several cracks in it, and this causes the rail to get loose. So I remove it from its place, and with the help of a steel wire, after I wrap it tightly around the shaft and with some epoxy above it, I was able to make this shaft work like it should be. After the epoxy dried out, I resecure the tuning rail into the variable capacitor shaft with its holding screw, as we can see. After the tuning rail it is fixed, it is time to do the threading of the tuning thread. Now, earlier I told you that the tuning thread it has been replaced, but after I carefully examined the tuning thread, it turns out that this is the factory tuning thread, and it did not been replaced because of the quality of it and the way it is constructed. Now, usually from the factory from the factories, they use a white type tuning thread, but this time, as we can see, it is black. So after some work, I was able to thread it into the correct way, like it is supposed to be from the factory. Now, after I threaded, I started the examination about why did the tuning thread misaligned and become loose. And it turns out that the tuning rail, if we take a look or a closer look to it, it has these grooves that the tuning thread or the tuning thread is supposed to be wrapped around it. So what happened is that when this rail it got loose, this tuning thread it missed the tracks and it just split. So this what causes the tuning thread to be misaligned with its tracks. So after the tuning rail it is fixed, there is no way that these or this tuning thread it can split anymore. Also, I bent this metal post that hold this rail into its place in order so I can make the tuning thread to be aligned with the rail threads. So after this part it is finished, the radio section it is completely repaired and I was able to move to the next step. Now the second step in the repairing / modifying process, it was replacing this board. Originally this board it has the voltage regulator power supply, and they use for the positive side a transistor and a circuitry that control it, but with the negative side they use a Zener resistor configuration. And if we take a look at the original board, we can see that the original board uses this transistor as a regulator for the positive side, and for the negative side they use another resistor and a Zener in order so they can regulate the minus 15 volts. The transistor role it is for regulating the plus 15 volts. So this board that I designed, it has a transistor regulator circuitry that regulate the plus and minus 15 volts. And also it has a VU meter circuitry, because the original circuitry or this circuitry it allow the uses or the use or the usage of these multimeter or VU meters in order so it can monitor the signal when the unit it is in the record mode, but it doesn't display the signal level or anything else. Except in the radio section, it is automatically shows the signal of the channel that it was tuned by the radio circuitry. So after I redesigned and made this board, I designed a special circuit that allowed these VU meters to read the signal output of the power amplifier. And with the same design of the original circuitry in the signal control section, I was able to produce this really cool signal control board. Now if we remove and put this board aside, I will show you the new function of this board. Now all of these VR pots remain the same. Also these switches remain as the same function like it was before, except for this VR resistors Originally, this VR resistor, it is designed for adjusting the record level for the tape section, but after I redesigned the circuitry, it purpose or it serve as a control for the volume of the MP3 module. Also, I redesigned and rewired this key in order so it can switch between the function of this VU meter, in order so it can, in this position, it can read the signal strings of the radio channels, and in this position it can read the signal output of the power amplifier. The next key, I cancel it, and as we can see, I cover it with some epoxy and I paint over it with some black paint. As for the speaker selector switch, it is back into the original function. Also, I patch this switch up, and also the counter window and the counter reset switch. And here is the MP3 that module that I installed, and this is how I install it and secure it into the body of the unit. Now, after this section it is over, it is time for moving to the amplifier section and see how I designed and built the amplifier section for this unit. Now, here is the amplifier section that I designed and built for this unit. Now, originally this unit, it uses the SI-1120 two chips, and that is a one channel for every chip. When I was trying to design a replacement circuit, I thought with an amplifier circuit that uses transistors, but that circuit, it turns out that it will cost me a lot of time and effort. So I decided to use an SDK module instead. Now, the SDK that I got, or the SDK part number that I got, is I only have the SDK 4142, and this SDK, it is capable of producing a 25 watt at every channel. But according to the specs that the factory provide for this model, the SI-1120, it is capable of producing a few watt per channel. So after some testing with the power supply, or the power that the transformer is providing, it turns out that the STK 4142II, it is capable of working with this type of voltage that this transformer, it is capable of producing, and it can indeed generate around 15 watt with a very clean and clear signal. So I designed the amplifier board with a protection circuit built into it, and I install it into the unit, as we can see. Now, the STK 4132II will work more compatible with this type of transformer, but I don't have it. And if I want it, I want to order it today from my usual suppliers in Taiwan or in Malaysia, with the shipping prices these days, it is going to cost the owner a big number. So I use this SDK because it is available. And in the testing footages that we are going to make afterward, we will see that this thing, it is turned out to be very compatible with this transformer. So after I redesigned it, redesigned the power supply and designed the amplifier circuitry, I reinstall it and secure it into its place, as we can see. And also I designed this board that hold a fuse as a main fuse for the transformer. Now the original design that this unit has, it doesn't have a main fuse. That is really interesting. As we can see, this board, it has two plastic stands, and they hold this fuse board into its place. Now, if we take a look under this board, we can see that also I installed two fuses, and also I can protect the SDK, and also I use a 3 amp type diodes as a bridge circuitry, and also I can get the power for this SDK. Also I use 4 3300 microfarad on 35 volts. Now this same circuitry with some modification and replacement of parts, around 16 parts, the same circuitry, it can produce up to 100 watt of true RMS of audio power. And of course the power transformer needed to be replaced, but this is what I designed and this is what I built. So after I did this step, the unit, it is completely ready, and now we are going to connect this unit to my test gears, and we will see how this unit, it is going to perform. So here's the unit, has been connected to my test gears, and now we are going to power it on and see what this unit, it is going to produce. So here we go. Here's the power switch to the on position. Here is the speaker terminal set to the A that I already connected the oscilloscope and the 8 ohm loads to it. Let me select the AWACS input, because I connected my signal generator to the AWACS input of the unit, and as we heard, here is the protection relay has been kicked in, and that is really nice. Let me reset all of these signal control pots. Here is the pass key, has been set to 0. Here is the treble, also set to 0, and here is the balance key, has been also set to 0. And let me boost up the volume and see what this thing, it is going to produce. Here we go. We are starting to get a motion on the oscilloscope. Here we go, and this thing, it is clipping with the volume key about 3/4 of the way. So what I'm going to do now, I'm going to pause this video and readjust these signal control pots, readjust the sensitivity of them, because these pots, their role in the circuit is to adjust the amount of signal that it is going and passing to the SDK input, in order so I can match the sensitivity of the SDK to the signal that it is generated in the preamp circuitry. And then I'm going to readjust the the pods that they control the VU level meters. So here's the signal control pods that control the signal to the SCK has been set to the correct position, and here is the trim pods, or the pods that control the VU meters has also been set to the correct position. And now we are going to boost up the volume and see what this thing it is going to produce. So here we go. As we can see, the signal on both channels, they are the same. And here is the clipping. Let's back off a little bit. Here we go. Now, according to the DMM, this channel it is giving a 11.3 volts, and that is really nice. Let's switch to the other channel, and the other channel it is giving 11.3, and it is almost the same as the previous channel that we tested. So these channels are producing a very clean sine wave at these levels, and appears to be they are working fine like they should be. So if we lower the volume and we grab the calculator, now turn it on, 11.3 multiply it with 11.3 equals 127.69 divided by 8. This thing it is giving up to 16 watts of true RMS power, and that is really nice. It is very close to the specs that the factory providing. Wow. So I believe we have now a working amplifier, and what I'm going to do, I'm going to disconnect my test gears and connect the speakers and see what this unit it is going to sound like. So I disconnected my test gears from the unit, and I connected two speakers to a speaker terminal A of it, and now we are going to start the testing by with the MP3 section in the unit. So here we go, and here is the MP3 has been selected, and here is the signal of it also has been selected, and here is a flash drive. Let's install it, boost up the volume to this level, it is okay. As we can see, the MP3 started to work, and let's boost up the volume and see. As we can see, it sounds really good. There is treble, there is bass. Wow, the bass it is very strong and very clear. That is really nice. There is the VU meters, they are working like it should be.
Are you ready? I swear. Are you ready?
Wow. The MP3 section it is working and working really well, and the sound of it it is really clear and really strong. So let's switch to the radio section and see what the radio circuitry it is going to sound like. And here is the radio. Let's boost up the volume. Here is the FM has been selected. Here is one channel. Now I haven't connected an antenna to the antenna socket of the unit, but in order so I can test the sensitivity of the radio circuitry, because if the radio circuitry it worked and received a channels without an antenna, this tells us that the radio circuitry sensitivity in it is very good. Let's select another channel. Here's another one, and here is another one, and there is another one. As we can see, the radio circuitry, it is working like it should be and receiving channels like it should be. Wow. The radio, it is also working like it should be, and there is no problem in it. Wow. So this tells us that the radio circuitry, it is working like it should be, and the amplifier section, it is working like it should be, and also the MP3 module that I designed for this unit, it is also working like it should be. And the unit, it is done and ready to be completely reassembled and delivered to the owner. So what I have to do now, after we confirm that all of these sections are working like it should be, is to reinstall the back cover and secure it with its holding screws, and my job here, it is done. So in the end, I hope you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.